So let's start with a brief recap of chapter lecture 4. So in the lecture 4, okay, we have this process management. In the last lecture, we have covered what is a process. The main idea that whenever you run a program, you start running a program, we call that a process. So a process is a program in execution. Then we have seen what is a process management, the basic idea. And we have seen what is a PCB, process control block, and what are the elements of PCB. We have seen that a process has a unique identifier, a process has different states, a process have priority, program counter, memory pointers, context data, IO status information, accounting information, and so on. Okay, and then we have seen that what is a trace and what are the importance of trace and what is a dispatcher. So there was an example that we discussed in the last class. So given you are running 3 programs at the computer at the same time, what role the trace plays and what roles the dispatcher plays. We have seen that given let's assume there is a 3 process A, process B, and process C. What the trace does, it actually keep tracks of how far a process is being completed. Okay, so let's go to the next slide. So here is a demonstration. So first we started with process A. The process A situated in the memory location 5000. So we are executing instructions from process A. So started with 5000, 5001, 5002. We are sequentially executing one instructions at a time. And suddenly after 6 seconds, okay, or 6 CPU time, there's a timeout. That means now we will move to another process. We are multitasking. We are at the same time we're listening to, let's assume we're browsing the Facebook, we're listening to music, and we're playing games. So computer needs to allocate time to all of them. Okay. Then there is a timeout, and then when there's a timeout, the dispatcher program is called. So dispatcher program, what it does, it actually switches from one process to another process, and for that, okay, what it needs to do, it actually save instructions of process A, okay, or the context of process A, and loads the instruction of process B. So here we can see the process B is loaded and the execution starts from 8000, the first instruction of process B. And then until 4 instruction occurs, suddenly there's an interrupt request. So we know what happens there is when there's an interrupt request. The interrupt service routine is called. That means the CPU stops whatever it is doing. Okay, it checks the priority and then it loads the new program. So again, if you want to load the new program, you need to actually you use the dispatcher. The dispatcher, which is also a program, a small program situated in the memory location 100. So from 100 to 105, all the instructions are executed. Okay. And then this program C is loaded into the memory, and it goes on like this, if you see step by step. So either there's a timeout or there's an interrupt. In this way, we keep switch between processes. Now, one thing that you can actually relate. So here, as you can see, that we are keeping track that how far we have completed of each process. So this is called trace of process, or trace of process A, trace of process B, trace of process C, and so on. So in this way, what we are doing, we're keeping track of how far we have completed each process. Next, we have talked about the process creation, that whenever we're using a computer, whenever we turn on the computer, the operating system actually creates one process after another process. The reason for creation of process might be new job, bad job, that means you're doing something new. It might be interactive login. Okay, it might be, oh, you're not seeing the slide. So there's a different reasons we can actually create a new job. It can, or we can also, sorry, new process. it can be batch job, it can be interactive logon, it can be created by operating system to provide a service, it can be spawned by existing process. So we have seen some example for each cases. For example, created by operating system to provide a service. So whenever you actually run your start your computer, so what happens that let's assume that you are trying to connect to the internet. So what you will do, okay, whenever you're trying to connect to the internet, the first thing, oh sorry, slide changed. So first thing you need to do is to actually make sure that you have a Wi-Fi, or you are actually if you're using broadband, you have a dial-up connection. So you first connect to the Wi-Fi or broadband connection, and then if you open the Chrome browser, it automatically connects to the internet. So behind the screen, a lot of other processes are actually being created and then executed and terminated without we ever knowing. So how we can check how many processes are running in a computer? So I have shown you that if you go to the task manager, okay, and from the task manager, there are different options, and you can actually go to services or processes. So let me show you here again.
Yes, sir. Yes, sir.
So as you can see, the task manager here, okay, we have, you see the name of different processors, and you see these are the process that is currently running in my computer. Then each process have a process ID. Okay, that each process have a status that's they are running. You see this process lock app, Microsoft Photos, this process is suspended, that means they are actually not running. And then there is a search UI, this is suspended. So these are two stages that you can see here. Okay, so some of the processes suspended and the rest of them are running. You see how many processes running in the Google Chrome. Every time you create a new tab, that is actually a new process. Okay, and you see here in the Google Chrome, each of the processes have different process ID. So that means even though Google Chrome is a one single program, but it has many childs or processes. And that's why, okay, sometimes we think that why Google Chrome makes my computer so slow, or why it takes so much RAM, because you see each process having its own memory allocation. You see here the username and the CPU, and then there is a memory. So that you see the same Google Chrome sometimes taking huge memory, sometimes it's taking very small memory, and it goes on like this. So let me go back to the PDF. So here we are back to the PDF. So as you can see that there are different reasons we can actually create process. And when we create process, there's a term called parent process and the child process. So we have seen that when a process creates another process, he is the parent and the process he created is the child. It's just same way as the human. So let's see an example. This root is the parent process and these are the child process. Again, init is the parent process, these are the child process, and it goes on like this. So last thing we discussed here in previous class, that in a process creation, okay, there are some important terminals like resource sharing, execution, and address place. So what is the resource sharing? That parent and child share all the resources. Parent and child share subset of parents resources, and parent and child share no resources. One example that I talked, that let's assume that you have parents have like 100 millions of taka, and whenever a child is being born, so a parent and child actually share the same bank account, okay, or same house, or everything, okay, all the resources the parent have. So we can say that in some cases, okay, even though it might happen that your parents might not be sharing their bank account with you, they are actually sharing the same house with you. So in some cases, or some parent and child share all the resources. In some cases, instead of sharing the same bank account, what the parent can do, it can actually take, like, assume your parent have 100 million, and from that he takes 10 million and gives it to you, that you can use this amount of money for doing whatever you want, but not more than that. Okay, so this is called the subset of parents resources. And then parent and child share no resource. So like your parent have 100 million, but you are getting none of it. Okay, so you have to get your own resources. And then whenever we are executing a program, parent and children can execute concurrently, without any connection, or parent can wait children to terminate, so it actually looks over to the children. And then we have the address space. So child actually duplicate the parent, so everything the parent had is duplicated or it can actually get a new program loaded to it. So these were all the options that we have discussed in the last class. Now today, the topic is very simple. So we start with process termination. That means we know whenever we create a process, but at the same time, there are different reasons for which we actually terminate a process, or that means we exit the process. So let's go to the definition. Process executes last statement and asks the operating system to decide to exit. So one simple example, that you are running a process and each process has a set of commands. Whenever there's exit command, okay, the process ask the operating system that I want to exit, okay? And then what happens, that output data from the child to parent, okay, via wait. So wait is actually a function that we will discuss from the book, okay? But for now, let's assume that every time a child process wants to actually exit, that means it is done, what it does, it gives the result of whatever you have done so far, okay, to the parent. So it might be a result of a calculation, okay, or it might be just they have displayed some of the options and then they're done. So if I talk about Google Chrome, and in Google Chrome, from the parent we have many children's. So what might happen, that in one Google Chrome tab, let's assume you were watching a YouTube video, and that tab was a child tab. That means it was created by another tab. Now what happened, that whenever you actually press close or the exit of that tab, okay, it actually asks permission from its parent tab that I am done, can I go? Okay, so it's like a very good child, okay, it takes permission. So if it has the permission from the parent, it exits. Sometimes it doesn't need the permission. All it needs to do, it actually output the data that I have done this work and now I am going, okay. Or sometimes what happens, okay, is none of this. What happens, the program starts, okay, it actually executes, and automatically whenever the execution is done, it actually exits. Now what you can do to test this, there is some programs that in your computer you can actually run. For example, one thing that you have done in many times, that there is a option called, if you go to your command prompt and type tree, you'll see what happens, that a program is being called and all of your files that are actually not in order, there's order is they're allocated in the memory properly, and speed of your computer actually increase a little bit, okay. So I think many of you have tried that, the tree. So just go to your command prompt and type tree. You will see a program will be called, a program will be executed, and then it will automatically will be exited. So the child process can be terminated in many ways, okay, but the main part that I am discussing here, that if a program is terminated, it will either give you output, okay, or it will give you a result, or it might just exit, okay, because some cases there is nothing to show, that you are watching a YouTube video and you suddenly decide to exit, so there is nothing to be given output, okay. But it will use a function called wait. So what is a wait? So it will actually tell that I am trying to exit. So do I have your permission? And or I want to exit. Okay, do you need anything from me? So that is the task of the wait. We'll discuss it more details in later. Then process resources are deallocated by operating system. So whenever you are running a process, what happens, that each process gets some resources that we clearly know. Okay, we have seen whenever I open the task manager, you have seen that each process is allocated some memory and so on. So what happens, that whenever a process exists, operating system, what it does, it allocates the resources it had back to the free memory or to the parent process or so on, depends on what it was doing. Then parent may terminate the execution of the child process. This is called abort, okay. In child has exceeded the allocated resources. So let's go back to again the money example. You had 100 millions, your parent had 100 million, and from there they gave you 10 million to spend, and you actually ended up spending all the money. So you are out of resources and you are wanting to new money. In that case, you will be terminated, that your facilities are over, give me back my credit card, you are not getting any more money, so you are done, okay. Or you are actually done with the task assigned to the child. So these are the two reasons the parent actually terminates the children. By abort, so you are either exceeded the allocated resources, okay, or the task assigned to the child is no longer required. It makes sense, right? In these two cases, parent terminate the children. And finally, the parent is exiting. So it might happen that you are shutting your computer down. Okay, so whenever you're shutting your computer down, the operating system, the program that runs all the time, it we can call it the parent process. So what happens is the program, the parent process is executing, and it actually doesn't allow any other program to continue. So just same way, if you actually shut down the computer, okay, what will happen if you shut down the operating system, uh, all other process will be terminated as well. So this phenomenon is called cascading termination. So why it is called cascading termination? Because if I go back to this slide, so if you just suddenly terminate the init program for some reason, what will happen? Okay, all of this, okay, step by step, all of this will be terminated. Okay, the user will be given a warning that we are closing down the processes, and if you want to save your work, save or exit, and you'll see the automatically very fast step by step all these programs will be executed. Now there are different reasons for those which can be a process can be terminated. It can be normal completion, that a process executes an OS service and indicate that it has completed running. So this is very simple. Time limit exceed, a process has no longer the specified total time limit. And sometimes you see whenever a computer hangs, okay, we can actually use task manager, and we can also use this feature. So here what happens, whenever a process no longer actually responding to you, the task manager actually gives you a notification that do you want to close the program, it's taking too long time to actually what it's called to respond. So in that case, you can actually shut down a program. Memory unavailable. Okay, you're trying to run a software or a program, but you don't have any memory. In that case, your computer might crash, or you might need a restart. Bound violation. So this one is actually a little bit different. So what does this mean? That you have memory, you have time limit, but the process tries to access a memory location that is not allowed to access. So each process are given a set of memory to access. So basically, let's assume that you have we have many houses in Uttara, but there is only one house that you live in. Okay, so you have access permission to that house, but for the other houses, you don't have any access permission. So this is called bound violation. So it might be for different reason, like you are taking one class, but you're trying to enter another class. So this can be considered as a bound violation. Okay, and same way for the process is doing one task, or it has the permission to access one memory, but it's trying to access another. In that case, a process will be considered as threat and it will be terminated. Okay, and then there's a protection error, that a process attempts to use a resource such as file that is not allowed to use, or is tried to use it in an improper fashion, such as writing to a read-only file. So let's talk about YouTube. So what is the purpose in the YouTube? You can go there, you can watch different videos, okay, but you don't have the right permission in the server. That means you cannot edit or delete a video unless it's your channel. So this is type of called protection error. So if a process suddenly tries to change a file that it doesn't have permission, the process gets terminated as it is treated as a security threat. And finally, the arithmetic error, the calculation error. So these are the 6 reasons. There is some more that the process gets terminated. So next you see time overrun, that a process has waited a longer time than specified for an event to occur. Then IO failure, you're trying to take input, but it's not getting an input or output. There's an invalid operation. Okay, such from reading from the line printer, the printer is not working. Invalid instruction, you have given a command, but process actually tries to execute the command, but this is actually non-existent instruction. There is no instruction available. Okay, like you have given the instruction read from memory location 5000, but there is nothing in the memory location 5000, or there is no memory allocation named 5000. Okay, maybe your computer has up to 4000 and so on. Then there's a privileged instruction. This one is a little bit difficult to remember. So what happens, the process attempts to use an instruction reserved for the operating system. So if you remember in the chapter 3, we have read about kernel mode, user mode. So different process have different ring of access, ring 0, ring 3. So if a process trying to actually execute or use an instruction that is not reserved for it, it might be terminated as well. You can compare it with this bound violation as well. And then we have the data misuse, okay, and then operator OS intervention. So for example, you are running in a process, it is doing everything by the book, but then suddenly there's a deadlock. What is the deadlock? We'll discuss it into the next chapter, that is chapter 6. Okay, but for now let's assume that sometimes what happens that you are doing everything right, but operating system is still may terminate the process for various reasons. And then the parent termination that we discussed previously, that if a parent terminated, the child is terminated as well. And parent request, so parents sometimes might request to terminate a child as well. So these are the various reasons, okay, that a process gets terminated. What you have to study from this, you have to remember at least 6 to 8 reasons for process termination. This is number 1. And number 2, you have to actually know each of these reasons. Like if in the exam I might ask that what is the reason for process termination in case of data misuse, so you have to explain what does data misuse actually mean and why the process gets terminated. If you don't have the clear idea by reading this, you can go back to the book, or you can search in the internet, or you can ask you can also ask me if you can't find there. So these are the reasons for process termination. Now, the next one is the model. So you see here, we have seen that the process can have different models or different states. Okay, so a process, there's a two-state model. There is, after two-state model, we have five-state model, and we have, there's another mixture with different transition as well. So there are different types of models for processes or the states of process. So today we will discuss about this 3 type of model. So first of all, we have is two-state model.